And for this example, again, it's the product rule, because you have x to the 5th times 3x squared. Or sorry, tangent 3x, what am I saying? And so I want to think u is x to the 5th, v is tangent of 3x. And the derivative of u, 5x to the 4th. The derivative of v, again, you have to think that it's not just tangent x, it's a tangent of 3x. So this is, again, the chain rule, in that I'm going to take the derivative of the big function. The big function is tangent. And it says the derivative is 1 over cosine squared of 3x. And then I need to take the derivative of what I put inside tangent. So the derivative of 3x is 3. Now, again, I know I've done this a lot. I can see how this is the derivative of tangent of 3x. And then talk it through one more time so that you hear again what I'm thinking. When I look at tangent of 3x, tangent is the big function. In the chain rule it says, take the derivative of the big function, multiply it by the derivative of the function you put inside. That's what the chain rule is all about. So the derivative of the big function, tangent of x, is 1 over cosine squared of x. And 3x is taking place of x here. So that's why I'm writing 1 over cosine squared 3x, because this 3x represents the x here. There are too many x's. But then the chain rule says, once I've done the derivative of the big function, take the derivative of the function I put inside, which was simply 3x, and that's 3. Once I have, again, the 4 pieces of the product rule, I'm now ready to work out the derivative. Leave the first, multiply it by the derivative of the second. I'm going to call it 3 over cosine squared 3x, plus leave the second, multiply it with the derivative of the first. Simplify if possible. There's not a whole lot to simplify. You can write, if you want, this to be 3x to the 5th over cosine squared 3x, making it a single fraction versus a number of times a fraction, and 5x to the 4th tangent of 3x. And that's essentially it. Now, this is not part of the syllabus, but you go off to university and talk about this and do this. I guarantee a professor is going to be like, what do you mean you never learned this? And that is, where do I write this? 1 over cosine x is basically the reciprocal of cosine of x. And mathematicians have actually given that its own function, which is secant, is the name. And so sometimes, in fact, if you do some practice problems from the PDF I gave you, you'll see that instead of writing cosine squared of x, well, they call that secant. And so another way this could actually be written is 3x to the 5th secant squared 3x plus 5x to the 4th tangent 3x. Why did mathematicians give 1 over cosine of x its own function? The same is true for 1 over sine of x, 1 over tangent. It's probably so that we're dealing with nicer looking equations than thinking of it as a fraction. Yes, it does have more applications. But what I want you to just know is that you will see often, instead of writing over cosine of x, they change it and call it the secant of x. Like I said, this is outside of your syllabus, so you don't have to worry about it. The blue is the final acceptable answer, but I don't want you to head off to university not ever having been told that 1 over cosine is actually 1 over secant.